Alright, welcome back. This is lecture 4 in this course on mathematical tools. The topic of this lecture is graphs and equations. In this lecture, we are going to take some examples of different equations and I will illustrate how to draw those equations on a two-dimensional xy plane as a graph. Okay. And we will also take examples of equations of a straight line, which we briefly covered in the previous lecture. Okay, so mostly I will take a lot of examples for your practice in this lecture, and I will also give some in-class exercises that you can practice with me. All right, let us begin. So I introduce you to idea of graph. So basically, you can represent a mathematical statement involving two variables, let's say y and x. Let's say something like y is equals to x square on a two-dimensional coordinate system where you have two axes perpendicular to each other, and let us call these axes x-axis and y-axis. Now you can represent any mathematical statement about two variables. For example, this. Now this is a statement which says y is equals to x square. Now you can represent this statement on this two-dimensional plane. How? Well, you can take different values of x, and corresponding to each value of x, there would be some value of y. So here y changes as a function of x as x changes, right? Although this relationship would depend on exactly what is this statement. So in this case, y changes as x changes in somewhat this fashion. So this is how the graph of this mathematical statement looks like. Now this xy plane is such that these are two real number lines perpendicular to each other going from minus infinity to plus infinity in both directions, right? So this is how the two-dimensional plane looks like. Now this curve representing this statement in this two-dimensional plane is called a graph of this statement, or graph of this curve or function in case we use functions, right? So this is the idea of a graph. You can have a graph in three-dimensional plane as well, but mostly in this course we will be dealing only with these two-dimensional graphs. Okay. Now first we begin with how to represent any equation on a graph, right? So representing an equation on a graph. So this is actually simple for very simple statements, but as your equation will become more complex, you will need some more tricks and you will need to take some decisions as well, right? So let us start with some simple equations. Okay. So let us say one equation is this: y is equals to 2x plus 1. Now this is a simple equation where x is exponent 1 and y is equals to 2x plus 1. What it means is that y is equal to 2 times of whatever is the value of x and then 1 added to it, right? Often in these equations you are given a range of values of y and x. If you are not given, then you need to figure it out yourself, right? But usually x and y can take any real values depending on the constraints of this equation. Sometimes the equation might constrain them to have only a particular set of values, right? In this case, x and y both can take real values. You can actually test this, what values they can take. We will come to that when we study functions. Okay. So here, let us say x can take any real value. Y would also be able to take any real value because it's simply 2 times x plus 1, right? So how do we draw the graph of this equation? So one simple idea is to take a lot of values of x and calculate corresponding value of y. Now what values of x should I take? Of course, x can take any real value, but we just need to test it for, let's say, 7, 8 values to figure out what the shape of this curve, what the shape of this equation would look like on the graph. Okay, we just need to figure out the shape and some critical points. For example, where does the line or this curve cuts the x-axis? where does it cut the y-axis. So we need to figure out those critical points. Okay. So for example, first critical point, where does this line cuts the y-axis? So at that point, the coordinate of x would be 0. Okay. You can see it for yourself. Let's say this is your xy plane. Okay. I want to figure out where does any line cuts the y-axis. So this point would be here. Okay. So at this point, the coordinate of x-axis would be 0. Okay. So we need to calculate value of y corresponding to x equals to 0 for this equation. For which equation? Y equals to 2x plus 1. So what would be the value of y when x is 0? So when you plug in x equals to 0, you will find that the value of y is 1. Okay, fine. Now let us see how the value of y changes as you go towards larger positive values. Okay, so as you go towards 1, 2, 3. Okay, so as you go from 1 to 3, let us see what would be the value of y. When x is 1, y will be 2 into 1 plus 1, 3. When x is 2, y would be 5. When x is 3, y would be 7. Let us see how it would change if we go into negative direction. So let's say x is minus 1, then y would be minus 2 plus 1 minus 1. If x is minus 2, y would be minus 4 plus 3 minus 3. If x is minus 3, then y would be minus 5. Okay. So as x is becoming more and more negative, y is also becoming more and more negative. That's the kind of relationship they have, right? Now let us draw all these coordinates, all these points on this xy plane. So let us first represent the coordinate 0, 1. So when x is 0, y is 1. So that point would be somewhere here. And when x is, let's say, sorry, I'll just draw the y-axis again. Yeah. So when x is 0, y is 1. When x is 1, then the value of y is 3. So x1 would be somewhere here. So corresponding to this, the value of y is 3. Similarly, when x is 2, y is 5. So let's say somewhere here. Okay. Now let us go into negative direction. So when x is minus 1, y is also minus 1. So when x is minus 1 here, y is minus 1. So this point would be here. And when x is minus 2, y is minus 3. So minus 3 would be somewhere here, right? So this is how this point would look like. Okay. So when you join these points, you will get the shape of this curve on xy plane, and you will see that it looks like a straight line when you join these points, right? So this is actually the graph of the equation y equals to 2x plus 1, and this line cuts the y-axis at 0, 1 at this point, and it also cuts the x-axis at some point. You can actually figure that out. Where does it cuts the x-axis? Well, the point where it would cut the x-axis, at this point the value of y would be 0 and the value of x would be minus 1 by 2. Okay, so this point would be minus 1 by 2 and 0. So this is the graph of the equation y equals to 2x plus 1. Let us try slightly tricky graphs. Okay, so let us try this. How about y equals to 1 minus x square? Okay, let us try this. Now I'll plot the xy plane first here. Let us take values of x and y. Let us try some critical points. Let us see what would be y when x is 0. When x is 0, y would be 1. Okay. What would be y when x is 1? When x is 1, y is 0. What would be y when x is minus 1? When x is minus 1, then y would also be 0, because minus 1 square would be 1, 1 minus 1, 0. That's interesting. So y is 0 at both x1 and x minus 1. Okay. So how does this graph behave? So if we just draw these 3 points at x equals to 0, y is 1, At x equals to 1, y is 0. At x equals to minus 1, y is 0. So 3 points are like this. Okay. Now let us try some large positive values of x and large negative values of y. Let us try first what would be the value at x equals to 2. So at x equals to 2, y would be 1 minus 2 whole square. That would be 1 minus 4. So y would be minus 3. And what would be at x equals to minus 2? At x equals to minus 2, y would be 1 minus again 4 minus 3. So one thing you can notice is that the graph is symmetric. The graph is symmetric around the y-axis such that whether you take x1 or minus 1, it has same value of y. Whether you take 2 minus 2, it has same value of y. Okay, so we do not need to test everything for negative as well as positive because the graph is going to be symmetric. Okay, so the y is going to have same value. So let us just try what would happen if we keep increasing values of x versus when we keep decreasing values of x. Okay. So let us try something like this. What would be y if x is very large? So let's say 100. So when x is not 100, let's say 10. So when x is 10, y would be 10 1 minus 10 square 100, so minus 99. So a large negative value. Okay. So similarly, you can see now as you increase the value of x, you will get a large negative value for y. Okay, in both directions, whether it is negative x or positive x. So that is fine. So what it shows is that when you go towards large positive values of x or large negative values of x, the value of y would be a large negative value. So the graph is growing downwards. Okay, so something like this. So as you increase the values of x, the values of y's are increasing in the negative direction. Similarly, as you increase negative values of x, values of y are increasing in the negative direction. So graph is going something like this. May not be linear, it won't be linear because it's squared. So it would increase more rapidly. So something like this. So won't look linear. It would increase very fast. Fine. What else? Can you try something close to 0? So what if the value of x is very close to 0? So let's say 0 point, or yeah, let's say 0.1. So what if x is 0.1? Then the y is 1 minus 0.1 whole square. And 0.1 square would be 0.01. 1 minus 0.01 would be 0.99. What it shows is that when x is close to 0, then the value of y would be close to 1. So here, when x is close to 0, the value of y would be close to 1. Okay. So the value of y would look like this in this range. And when, let's say, and as value of x goes from 0 to 1, the value of y decreases from 1 to 0. You can see here. So when x is 0, y is 1. When x is 1, y becomes 0. So the value of y would decrease as you go from 0 to 1, as x goes from 0 to 1. You can try it for 0.5. So at 0.5, the value of y would be 1 minus 0.25, 0.75. It will keep on decreasing. Let's say 0.9. So at 0.9, the value of y would be minus 0.81, so 0.19, like this. So these points would be somewhere here. So basically the value of y keeps on decreasing as you go from, as the value of x goes from 0 to 1 or minus 1. And this point is 0, 1. So this is how the graph of this equation would look like. This is the graph of the equation. Y is equals to 1 minus x square. Okay, good. So if you notice, what is important here is that you figure out what would be the coordinates at some critical points, like x equals to 0. What would happen if you increase the values of x in the positive direction versus what would happen when you increase the value of x in the negative direction, right? And then at large values of x and at some critical values of x, let's say close to 0, close to 1, right? So these are the things that we need to check depending on the equation, right? Let us try one more difficult equation. Let's say the equation is y equals to 1 divided by 1 minus x square. Now this is tricky, and let's see if we can work out how this graph would look like. This is tricky for a particular reason, and the reason is this, that this this statement wouldn't hold when this denominator is 0, because when the denominator becomes 0, the whole terms becomes undefined, so we cannot evaluate that term at all, right? So this denominator 1 minus x square should not be equal to 0, because if it is equal to 0, then this statement would anyway wouldn't be valid, right? That would be undefined. So this denominator should not be equal to 0. So we can solve this inequality for x, right? So if this 1 minus x square is not equal to 0, that means x square should not be equal to 1, okay? Because this term would become 0 only when x square is equals to 1. So x square can't be equal to 1. That means x cannot be equal to 1 or minus 1. If x is 1, then this is undefined. If x is minus 1, then it's undefined. So x can't be equal to 1 or minus 1. So this graph, graph of this statement, graph of this equation will be undefined at x equals to 1 and x equals to minus 1. Now this is an interesting kind of graph. You haven't plotted something like this before now in this course, but you will see an example. So at x equals to 1 and x equals to minus 1, the graph would be undefined. Okay, so there won't be any graph corresponding to x equals to 1 and x equals to minus 1. But then let us see how the graph would look like. So let us try the values at some critical points. So what if x equals to 0? So when x equals to 0, value of y would be 1. What if x equals to, let's say, now we know that x can't be 1 or minus 1, but that does not mean x can't be 0.99. So x can be very, very close to 1 and minus 1. So let us see what would be the value when x is 0.9. So when x is 0.9, the value of y would be 1 divided by 1 minus 0.81, that is 1 divided by 0.19, right? So which is approximately so 1 divided by 0.2, right? So that would be 10 by 2, so approximately 5. So this is approximately 5. Okay, so when x is close to 1, value of y is approximately 5. What if x is 0.1? When x is close to 0, then the value of y is 1 minus 0.01. So 1 divided by 0.99. So that is 100 by 99. So this is actually close to 1. So when x is close to 0, value of y is close to 1. And this would remain the same even if you take minus 0.9 or minus 0.1, the value of y would remain 5 or 1, right? So what this tells you is that when x is 0, y is 1. But as the value of x is going from, so when the value of x is close to 0, then the value of y remains 1. But as the value of x goes close to 1, then the value of y is increasing. Okay, so y is increasing as x is going close to 1. Okay, so at 0.9, the value of y is around 5. It's quite large. Similarly, at x equals to minus 0.9, the value of y is again 5. Okay, so quite a large value. Okay, so the value of y is increasing as the value of x is increasing in either direction. Okay, but let us think, because x can't take 1, but what if x is really, really close to 1? So let's say x has a value which is really, really close to 1. So even more than 0.9. So let's say 0.99. Now the square of 0.99 would be close to something like, let's say 0.95 or 0.91, right? And if you solve this for y, And it would look something like 1 divided by 0.05, and that would be 100 by 5 would be 20, right? So this is even more, right? So it's a very large value when x is even close to x is, let's say, 0.99. What would happen is that as the x value of x gets closer and closer to 1, let's say 0.99999, the value of y would be very large, and it would actually increase exponentially. So you can see that the increase is not so much. The value of y has gotten from 1 to 5 when the value of x goes from 0 to 0.0 to 0.9. So it increased slowly in the beginning, but as you go closer to 1, then the value of y would increase sharply. I am drawing this x equals to 1 line here, and this is x equals to minus 1 line. So what would happen as the value of x goes closer to 1, the value of y increases sharply like this. So this value of y would keep on increasing, and this curve would never touch this x equals to 1 line, because x equals to 1 is not possible, but a very close value of x, a value of x very close to 1 is possible. So this will keep increasing but will never touch this line. This is called asymptote. So this will become at some point parallel to this line, but it would never touch this line. So this is how the graph of this equation looks like between -1 and +1. Okay, so it increases sharply close to values of x equals to 1. But what would happen for values of x which are greater than 1? Would the graph behave differently? So let us take values like x equals to 1.1. What would happen at x equals to 1.1? So it would be 1 divided by 1 minus 1.1 square. So it would be 1 minus 1.21, right? So this is 1 divided by minus 0.21, which would be approximately 100 by 20, so minus 5. So x equals to 1.1 looks something like y equals to minus 5. So when the value is greater than 1 and close to 1, then the value of y is negative. Okay. If you take a large value of x, let's say 10, then the value of y would be 1 divided by 1 minus 100, that is minus 1 by 99. So this would be a quite low value and low negative value. So somewhere around 0.01. So minus 0.01. Okay, so when x is 10, the y is somewhere around minus 0.01. So somewhat like this. And you can try for some more values. So as you would go closer to x equals to 1, but x is greater than 1. So let's say something like 1.001. Okay, if you take a value of x like this, then the value of y would be a large negative value. Okay, and as you take very large value of x, let's say x equals to 1000, then y would be a very small negative value. So the graph on this side would look something like this. So as you take very large values of x, it would, the value of y would be close to 0, very small negative values, and as values grow close to 1, then it would be very large negative value. And similarly on this side as well, the graph would look like this. Okay. So this is how the graph of the function 1 divided by 1 minus x square looks like. Now this graph is interestingly symmetric around the y-axis. Okay. All right. So this is the way you can draw the graph of very complex equations on the xy plane. Now coming back to equations of a straight line which were of the form y equals to mx plus c. So just to revise, this is the xy plane and m is the slope of this line. It tells you how steep is the line. If m is positive, the line would would be such that the value of y would increase as the value of x increases. If m is negative, then the value of y decreases as the x decreases. So, this line would have a negative m, this line would have a positive m. So, this is positive m, this is negative slope. C is the point where this line cuts the y axis. Okay. Now, understanding straight lines is important because this would become useful when you start doing linear regressions for your data analysis, right? So, in linear regression, we directly use the idea of a straight line. So, given any data, we find the best fit straight line that can represent your data or that can describe your data. Okay. So, when you want to find best fit straight line, we actually want to find the slope and the intercept of a line that can best describe the data, right? And that's why it becomes important. Okay, there are some properties of a straight line. So, for example, you can figure out when you are given equations of two straight line, you can figure out whether they are perpendicular to each other. So, when two straight lines, let's say y equals to m1x plus c1 and y equals to m2x plus c2, do they cut each other at 90 degree? You can figure it out. If they cut each other at 90 degree, then m1 into m2 would be equal to -1. Okay. And you can also figure out the point at which they cut each other. So, this would be the point which lies on both these lines. So, you just need to solve these two equations for a common point where these lines would intersect, right. So, you can try to solve a simple problem. So, let's say you are given equations of two straight lines. One is y is equals to 2x plus 1, another one is y is equal to minus 3x plus 2. So, can you figure out the point where these two lines, let us take slightly different. Let's say another one is x plus 2y is equals to 1, okay, or equals to 3. Okay, so, this is first line and this is the second line. Can you figure out the point at which these lines cut the y axis? And you also need to figure out whether these lines are perpendicular to each other. So, first thing first, are these lines perpendicular to each other? For that, we need to find the slope of these lines. For the first line, it is written like this in this form, y equals to mx plus c. So, the slope of the first line is 2. What is the slope of the second line? Write it in this form, y equals to mx plus c. So, 2y equals to minus x plus 3, y equals to minus 1 by 2x plus 3 by 2. So, the slope of the second line is minus 1 by 2. So, what is m1 into m2? It is 2 into minus 1 by 2. So, that is minus 1. So, yes, these two lines are perpendicular to each other. At what point they cut each other? Then for that you need to solve these equations. First is y equals to 2x plus 1. Second is y equals to minus 1 by 2x plus 3 by 2. So, if you solve these equations, let us subtract equation 2 from 1. Okay, so y will cancel out, 2 minus 1 by 2. So, it would become 0 equals to 2 minus 1 by 2 would become 2 plus 1 by 2x plus 1 minus 3 by 2. So, 0 equals to 5 by 2x minus 1 by 2. So, 5 by 2x is equal to 1 by 2, 5x is 1, x would be 1 by 5. And what would be y? Y would be 2 into 1 by 5 plus 1. So, that is 2 by 5 plus 1, that would be 7 by 5. So, these two lines cut each other at this coordinate, at this point. X coordinate 1 by 5, y coordinate 7 by 5. So, these two lines cut each other at 1 by 5 and 7 by 5. Okay, that is the solution. Okay. So, this is it from the lecture on equation and graphs. Now, you need to practice more on equations of the straight line because you should be able to solve problems like this. For example, what is the difference between line A and line B? So how these two equations are different, how these two lines are different, both are straight lines and their slope seems to be same, their steepness is same. So their change, the value of y changes at the same rate with respect to x in both a and b. What is different about them, that they cut the y-axis at different points. So their intercept is different, but the slope is same. Now what is different about line C? So line C seems to be parallel to x-axis. So what would be the slope of a line which is parallel to x-axis? The formula for slope is something like this. M is rate with which y changes. So let's say y2 minus y1 divided by x2 minus x1 with respect to x. What is the rate of, what is the change in values of y on this line? If it is parallel to x-axis, y does not change at all. So actually y2 minus y1 would remain close to 0, x2 minus x1 can have some value, let's say 1 unit. So slope is actually 0. So slope of a line which is parallel to x-axis, that slope of that line is 0. Okay, and if it is goes downwards, then the slope would be negative. Now the value of y is decreasing as the value of x is increasing, right? So you should be able to know these properties of straight lines by just visualizing them. You should be able to tell their slope and intercept. Okay? That's a very useful toolkit. All right, so I will stop here, and this is it on graphs and equations. In the next lecture, we will discuss functions. So what is a function and how do we draw the graph of a function on xy plane, which would be actually same as drawing the graph of an equation. But importantly, how do we find the domain and codomain of a function and how to find inverse of a function. Okay, so I'll stop here. Thank you.